Hi to everyone, welcome to today's video session. I Dr. E. Devi. Today I am going to discuss about designing flowcharts. The aim of this session to familiarize students with importance of flowchart and its usage in programming environment, to learn problem solving and designing techniques, various applications of flowcharts and its implications. Instructional objectives. This session is designed to define the basic concepts of flowchart and its implications, to define the programming logic design and techniques. Learning outcomes. At the end of this session, you should be able to design flowcharts to solve real-life computational problems, develop the flowcharts based on real-life conditions. Now, first of all, we'll see what is a flowchart. The flowchart is nothing but pictorial representation of an algorithm. An algorithm we previously discussed, the algorithm is nothing but step-wise procedure what we follow in order to solve a solution. That algorithm, whatever we are writing in a step-by procedure, can be represented in a pictorial form for better understanding. That pictorial representation of an algorithm is called as a flowchart. Flowcharts use simple geometric shapes to depict the process and arrows to show the relationships and process data flow. For each operation, a particular geometric symbol is there in flowchart for better understanding, and arrows are used to represent the data flow in a flowchart. Now we'll see what are the different symbols what we use in flowchart. So these are the few symbols which represents a particular action. The rounded rectangle is used to represent start and stop. You know that every algorithm starts with the start step and ends with the stop step, and in order to represent that start and stop, we go with the rounded rectangle. A parallelogram is used to represent input and output statements. Each algorithm takes some input and produces some output. Those input and output statements are represented with the parallelogram. A rectangle is used to represent a processing or computation. In every algorithm, we perform some calculations, and those calculations are represented with the rectangle. Rhombus is used for decision making. We previously discussed that we can go with the selection and iterative statements. In order to represent the selection and iterative statements in a flowchart, we use the symbols called as a rhombus, and arrows are used to representing the data flow. A circle is used as a connector in a flowchart. So these are the basic symbols what we use in our regular flowchart, and flowchart is nothing but a pictorial representation of an algorithm which is used for better understanding of your procedure. Now we will draw a flowchart in order to find the area of a rectangle. The area of a rectangle logic comes under into sequential statements. So first we will go with the formula. For area of a rectangle, this is the formula we are going to use: length and breadth. The inputs are length and breadth. The process, the formula L into B, and with the process we going to get an output which is nothing but area of a rectangle. So the algorithm for this problem is step 1 start, step 2 read length and breadth, step 3 calculate area of a rectangle length and breadth, and step 4 display the area of a rectangle. So this is the algorithm what we already discussed in the previous session. So this algorithm we can represent in a pictorial form which is called as a flowchart by using the geometrical shapes what we discussed in the previous slide. So the first step is start, and the start is represented with a rounded rectangle, and the next step is read L and B means input statement, and the input statements are represented with parallelogram. The third step is process means we are doing some calculation where we are calculating area of a rectangle. So for that we use the rectangle syllabus, area of a rectangle equals to length into breadth. The next step is displaying area of a rectangle means an output statement, and to represent the output statement we go with the parallelogram, print area of rectangle, and the last one is stop. Again the stop is represented with the rounded rectangle. So this is the flow chart what we are using to represent a flowchart in a algorithm in a pictorial format. So if you see this one, by seeing the flowchart, one can easily understand the procedure what we are following in order to solve your problem. Now we'll go with another example to print greatest among the two numbers. So here the greatest among the two numbers doesn't require any formula, it just requires some selection statement. So the inputs, the algorithm for this one is step 1 start, step 2 read A and B, the two numbers among which we want to find out the greatest, and step 3 here we instead of writing a formula we are writing some condition. If A is greater than B, then print A as a big, otherwise print B as a big. So the last step is stop. So here this logic is called as the selection statements. This algorithm will convert into a flowchart for better understanding. The first step is start, which is represented with rounded rectangle, and the next one is an input statement, a parallelogram, read A and B. Next here we are writing some condition, we are doing some decision here, and to represent the decision in flowchart we use a rhombus symbol. So rhombus, if A is greater than B, we kept the condition in the rhombus symbol. Now this is having two possibilities. One possibility is the condition may be true or yes, and the second possibility is the condition may be false or no. Now if the condition is true, then it is going to move towards the yes direction, and if the condition is true, it is printing A is bigger, and after that it's stopping the flow by going with the stop. So this happens, these statements will be executed when the condition is true. So not only the true, sometimes there is a possibility of condition no, means the condition may be false. So at that time the controller will move to no direction, and it is printing B is greatest one, and it is going to stop. So wherever may the control may go, either true or false, or yes or no direction, at the end it will come to the stop. So this logic comes under into selection statements. Here which statement to be executed, whether printing A value as a great or printing B value as great, is based on this condition, and this condition decision making is represented by using a rhombus symbol in the flowchart. Now we'll go with the one more example to draw a flowchart where the question is to print first n natural numbers. So this comes under with the iterative logic. So the algorithm is start, step 1 start, read n value up to which you want to print the natural numbers. Step 3 I equals to 1, we are initializing this one, I value with 1, and in step 4 until I less than equals to n, we are going to do the following statements, that is printing I value and incrementing the I value by 1, and these two statements printing I and I equals to I plus 1 will be executed until I less than equals to n. Now once the condition is false, the controller comes to the last step, that is nothing but the stop. So this algorithm can be represented in a pictorial form by using the previous discussed geometrical shapes. The first one is start. Here one thing we can remember, that to represent the start and stop, not only rounded rectangle, we can use a oval shape also. So start is represented here with oval shape. The next read n value means it is an input statement. So for input we go with the parallelogram, read n value. Then in step 3 we are assigning I value with 1, means it's some like assigning statements. So the assigning statements in flowchart can be represented with the rectangle I equals to 1, and then in step 4 we are checking some condition, means we wrote some statement like until I less than equals to n. So this can be represented in a flowchart by using a rhombus symbol. So I less than equals to n. If this is true, then go to the down direction and print I value. So printing an output statement, so parallelogram, increment the I value by 1 means some calculation statement, so should be represented with rectangle like this, I equals to I plus 1, and these two statements, that is printing I value and incrementing the I value by 1, will be repeatedly done until I less than equals to n. So this is called as a iterative logic. So the statements are executed repeatedly until the given condition I less than equals to n. If the condition is false, then the control is moving to the no direction, and the last step what we represented in algorithm is stop. So the control is going to the no direction and it stops the process. So this is a flowchart representation of an iterative logic. So the iterative logics are represented with the rhombus, and they'll be having two possibilities, either true or false. If it is true, it will repeatedly execute this one until the condition is false or no. So we discussed the flowchart. And what is a flowchart? Flowchart is nothing but a pictorial representation of an algorithm, and in order to represent or in order to draw a flowchart, we use some geometrical shapes. Rounded rectangle or oval is used to represent start and stop. Rectangle is used for process, and parallelogram is used for input and output statements, and rhombus is used for decision making, and arrows are used to represent the data flow. So using these symbols, we can draw our flow, we can convert our algorithm into pictorial form, which is a better understanding by the user. So the next one is self-assessment questions. So these are the few self-assessment questions. By using the previously discussed logic, you draw the flowchart for the following problems. So what we say that the algorithms and flowcharts are the two problem solving tools using which you can easily write a solution to your problem, which helps you a lot to convert that solution into a program. They are the easy way to solve your problem. Now these are some reference books for further learning of this session. So, and thank you all.